What up, what up? Today we're talking about standard form. Standard form is the equation of a line. Now, if you watch my videos in order, you're going to be like, another one? Didn't you show us slope-intercept form? Didn't you show us point-slope form? And now you're giving us standard form? Yes! Why, you ask? No reason. So let's get started. Standard form is what they used to back in the olden days. They used to use it back in the olden days. And that's what it looks like. AX plus BY equals C, where A and B are just numbers, and so is C. X is X and Y is Y. Now what's A? Nothing. What's B? Nothing. What's C? Guess. Nothing. You see, the reason why point-slope form was so convenient is it gave us a point and a slope. And slope-intercept was so convenient because it gave us a slope and a y-intercept. Standard form serves very little purpose, but no matter. No matter. I'm going to turn that guy into slope-intercept form and see if we can learn a few shortcuts. And guess what? We will. So let me get a pen. Let's go with green, my favorite color. I'm going to take that guy and solve for y. So the first thing I have to do is subtract ax from both sides, subtract ax from both sides, cross u out. This solves for by, so that's supposed to be a by equals, slope-intercept form is mx plus b, so I want the guy with the x first, so I'm going to write out negative ax positive c. Many of you might put, what about c minus ax? Sure, but I want this to look like slope-intercept form. Is it slope-intercept form? It certainly is not. So what I'm going to do is I'm going to divide both sides by b, which means you divide everything by b. And what that does is it tells us y equals a and b don't combine, so I have negative a over b living in front of x plus c over b. So what I just found out is if I give you something in standard form, my slope is negative a over b, and my y-intercept is c over b. My slope is negative a over b, and my y-intercept is c over b. So, I need to graph that. Well, that's standard form, isn't it? So let me label things. Your A, your B, and your C. My slope is negative A over B. So my slope is negative A, 6, over B, 2, which is negative 3. My y-intercept is C over B. So C, which is 12, over B, which is 2. So my slope is 6. No, my y-intercept is 6. Dummy. Sorry. Now we can graph it. So if you're thinking, can I just solve that by subtracting 6x and then dividing everything by 2? Yes. But if you want to do these in your head, which I can, I don't need to do that. I can just memorize a few letters and I'm in good shape. Let's put a dot at 6 because that's my y-intercept. 1, 2, 3, 4, 5, 6. My slope is negative 3, which is the same as negative 3 over 1. So I can go up 3, left 1. No, I can't. I can go down 3, right 1, down 3, right 1, down 3. Can I move my face? Down 3, right 1, down 3, right 1. And ladies and gentlemen, I have myself a line. Now there's another way that I can graph that, but I'll save that for later. Capiche? Looks like I'm doing it again. Oh, look, Standard form. Something x plus something y equals something. So I have a, which is my 4, b, which is negative 3, and c, which is regular 3. So my slope is negative a over b, so negative 4 over 3. That's my slope. There it is. And my y-intercept is c over b. So 3 over negative 3, which means my y-intercept is negative 1. So in order to graph it, I put a dot at negative 1 right there. My slope is up 4, left 3, up 1, 2, 3, 4, left 1, 2, 3, up 1, 2, 3, 4, left 1, 2, 3. And my face is in the way, but you know what? Ouch! Ouch! Right in the face. Nope, wrong way. Mirror. It's a mirror. Again, if I wanted to, I could have subtracted 4x and then divided everything by negative 3. But what fun is that? What fun is that? All right. The other way that we could handle these are dealing with the concept of y-intercept and x-intercept. You already know what a y-intercept is, and that's when you have y all by itself. The number that's floating around is my y-intercept. Great. There's another way that you can look at y-intercept. Okay. Any point that is a y-intercept is going to be the point 0 something, 0, 5, 0, negative 2. That looks like 0, regular 2. Okay. And an x-intercept, similarly, is when my y is 0. So that looks like negative 2, 0. So simply put, a y-intercept is when x is 0. And a x-intercept is when y is 0. So how do I solve? If I ask you, just like a regular old problem, hey, find the x-intercept, and you're like, I've never learned that before. Okay, well then make y equals 0, and then solve for x. Okay, and if I ask you to find the y-intercept, normally you would solve everything for y and then find the number floating around. But now I could just throw 0 in for x and then solve for y. And that'll be your y-intercept. So let's use that method to do this problem right here. And this problem right here, I ask you to find the x-intercept and the y-intercept. Let's move my face again for the 18th time today. Find the x-intercept and the y-intercept of 3x minus 6y equals 21. Let's start out by doing the x-intercept. To find the x-intercept, I'm going to rewrite that equation right there. But I'm going to plug in 0 for y. I'm going to rewrite that equation right there, but instead of y, I'm going to have 0. See? Negative 6 times 0, well, that just becomes 0, so you're pointless. Which is funny because we're talking about points. Not so much today. 3x equals 21. Divide both sides by 3. And my y-intercept is 7. Boom. That's it. Basically, you're just like getting rid of y and everything attached to it. Solve. To find the y-intercept, what I used to do is solve everything for y, but you know what? There's just an easier way to do it. And I'm going to rewrite that equation out, but instead of x, I'm going to put 0. I'm going to rewrite that equation, but instead of x, I'm going to put 0 minus 6y equals 21. You're pointless. Drop down the negative 6y, which equals 21. Divide by negative 6. Divide by negative 6. And the y-intercept is 3.5. Negative 3.5. Yeah, it is. Okay. So those of you who are getting used to this, you know, my method of doing like the y-intercept is I just kind of close my eyes and make the 3x disappear, divide everything by negative 6, and there you have it. Not so bad. Not so bad when you understand math. Not so bad at all. I'm going to ask you to graph. Negative 4x minus 3y equals negative 12. I'm going to label you A, I'm going to label you B, and I'm going to label you C because you're in standard form. Slope is negative A over B. Okay, negative A over B. So my slope is negative A, which is negative 4, over B, which is negative 3. I have a triple negative, which makes it negative. Because if I have 3 negatives, the double negative becomes positive, and I still have a negative left over. So I have negative 4 over 3. That's my slope, it is. Just because I don't have a ton of space, the way I find out what my x-intercept is I make believe that the y is 0, which makes the negative 3 go away. So I'm finding the x-intercept. I'm making that part go away, which means I have negative 4x equals negative 12. Divide everything by negative 4, divide everything by negative 4, and my x-intercept is 3. The way I find my y-intercept is I pretend that x isn't there, and I make everything in front of that go away, and so I have negative 3y equals negative 12, so I'm going to write that out. Negative 3y equals negative 12. I'm going to divide everything by negative 3, divide everything by negative 3, which means my y-intercept is regular 4 because negative 12 divided by negative 3 is 4. So if my y-intercept is 4, boop, boop, and my x-intercept is 3, I have 2 points. That's enough to graph. But I also found out that my slope was negative 4/3. So like if I wanted to, I can't go up 4 over 3. I don't have enough space, but I can go down 1, 2, 3, 4, right 1, 2, 3, and there I have another dot, and it makes it a little bit easier to graph if I would just hit all 3 of those dots. And that is not pointless because I had 3 points. Standard form, everybody. A lot of fun. Thanks for watching. Bye.